Let's prove this statement. A necessary and sufficient condition for an integer n to be divisible by a non-zero integer d is that n equals the floor of n over d times d. In other words, for every integer n and non-zero integer d, if d divides n, then n equals the floor of n over d times d. And part B, if n equals the floor of n over d times d, then d divides n. Let's start by proving part A. We're going to assume n is an integer and d is a non-zero integer such that d divides n. So then by definition of divides, n equals d times k for some integer k. Next, let's look at the floor of n over d times d. If we use substitution, n equals d times k, so this is equal to d times k over d times d, which is the floor of k times d. Now, since k is an integer, the floor of k is just k. So my answer here is just k times d. But k times d equals n, which is what we wanted to show. We wanted to show that this equals n. So that's the proof for part A. For part B, we're going to assume n is an integer and d is a non-zero integer, such that the floor of n over d times d equals n. The goal is to show that d divides n, which means that we want to show that n equals d times some integer. Now, since the outputs of the floor function are always integers, that means that the floor of n over d equals k for some integer k. So then that means n equals d times k, which by definition of divides means that d divides n. And these are the two proofs. Thanks everyone, and I'll see you in the next video.